So hello and hope you're doing good on my channel. Today we are at day 27 of the June Daily Code Challenge, and we have another interesting question for us. It's question 373. Find k pairs with minimum sum. At first, this I felt this is somewhat the easiest question to understand. But you'll realize that even after understanding, figure out which way will be most efficient. It will really take some experience, right? Let's see what the question is. So as you can see in the input, we are given two arrays. Okay, and we are given two arrays and integer k. Let us understand the meaning of each of them. Okay, you are given two integer arrays nums1 and nums2 sorted in ascending order and an integer k. So remember one thing, as you can see in the input itself, 1, 7, 11, these are sorted as well as nums2, 2, 4, 6, these are also sorted. So the elements of each of the given arrays are sorted and integer k is given to us as input. Okay, so what the question now is, see, define a pair u comma v which consists of one element from the first array and one element from the second array. Return k pairs, okay, k pairs with the smallest sum. Okay, what it means is, see, we have to take any one element from the first pair, we have to take any one element from the second pair. Okay, like that we have to form pairs first of all, and then we have to select, first, that is the first case pairs with the smallest sum. Okay, we will do a bit, let's first manually calculate and understand how it works. See, first I have, see, they are sorted, right? That means this element will be the smallest element in nums1. Similarly, this element will be the smallest element in nums2. Okay, so if I want the smallest sum, so I will add these two. Okay, 1 and 2. Okay, 1 and 2, if I add, I will get a sum of 3. So this will be my first pair. Okay, as you can see in the answer also. Okay, then what I will do is, then I will try to take the second largest element, which is 7, and then I will try to mix it with the smallest element. Okay, which will become 7 comma 2. Or we can do is, I will take the first one itself and take the second one from here. Okay, see what I'm doing now, I will trace and show you. See, in program also will trace and show you, but for now just try to understand this. Okay, see, it's sorted, so we have to utilize this fact to the maximum. Okay, first element is 1 comma 1. Okay, now I'm trying to find the second smallest element. I have two options. Okay, what I can do is, see, I can retain the first element of this array and I can go to the second element of this. Okay, or I can do is, I can retain the first element of this and I go to the second element of this. Okay, so the options are 1 comma 4 and 2 comma 7. Okay, 1 comma 4 is 5, 2 comma 7 is 9, so 5 is definitely smaller than 9, so I'll go ahead with this. Okay, so as you can see, 1 comma 4. Since 1 comma 4 is the smallest, I will go ahead with the other pairs with starting from that. Okay, what I can do is, see, 1 comma 4 is there. What I can do is, see, where is 1 comma 4? This is 1 and this is 4. Okay, the other one is obviously there. The other, what is the other one? 2 comma 7, which is 9, is obviously there. Okay, 9 is obviously there, but let us see this. See, 1 is here, 4 is here. Okay, now try to see. I will try to retain 1 and I can go to 6. Okay, it becomes 7. Or what I can do is, I can retain 4, I can retain 4 and go to 7. Okay, so it becomes 13. Okay, so definitely 7 is the smallest, so we are taking 7. See, which way I am taking, that is actually, you will understand while coding. Okay, because I have coded already, so I know that. But don't worry about that, but just try to understand the fact that we are making use of the idea that they are sorted. Okay, that's what we are doing. Okay, and remember, we will stop when we have the smallest, that is first three smallest pairs. Okay, that is the most smallest one, then the second smallest one, and the third smallest one. After that, we are supposed to stop. That's what we're doing. I hope this question is very simple to understand. You can just go through the statements once. Okay? All the, the theory statements, you can go through them again once. It's very simple to understand. And if you trace this example, I think that it should be enough for you to understand the whole question. Now let's come to the coding part. See, one thing is very clear, that what order we are going to take is very clear. Okay. For example, the first element will be the first. See, this smallest one will be 0 comma 0. What is 0? 0 is the index of the first element. The second 0 is the index of the second element from, sorry, the index of the first element from the second array. Okay, so I will represent 0 comma 0. Okay. Next element will be either 0 comma 1 or 1 comma 0, right? Whichever is the smallest, and from there on we will extend. Okay. For example, see here, I will give you this now itself, so that it becomes easy for you. So yeah, for example, see, when we are at 0 comma 0, what we did, please pay attention. We went to 1 comma 0. See, 0 comma 0 is included, right? And we are searching for the second smallest element. So which one we will test? We will test 1 comma 0 and 0 comma 1. Among them, whichever is the smallest, we will take that as the second element. Okay. So what generally we are doing, Siddhant, we will generalize. See, for every I comma j which is already inserted, for trying to find the second that is the next element after that. Okay, next smallest element after that, we will always try to check for this. I plus 1j. Let's see, I is here, right? Just add 1 to it, you will get I plus 1j. Okay. Otherwise, just add 1 to the j. Okay. Instead of changing I, just change the j. So I comma j plus 1. Okay. So this is the general thing which we will try. So always see. I will again repeat. See, one thing is here. See, 0 comma 0 is there. Okay. You included two elements. Okay. Let us say out of them, this one is the smallest. Okay. So when we know this one is smallest, this will obviously remain in the competition. Okay, this is see, for the next chance it will remain in the competition. But for now we have selected this one. So what are its successes? As we will follow this rule now. We will follow this rule now. Okay, so please try to guess what will be the successor for this 1 comma 0. It can be 2 comma 0. Okay, or it can be 1 comma 1. Okay, so those two and this remaining one, then we will compete with them. Okay. So which is the smallest among them will be now taken, and it will be further. There will be two success for that. So idea here is at every step, we'll take out the smallest one and the one who is being taken out. It will lead to two more successors getting in. Okay, that's what we are going to do. And I think by now you would have understood that we are going to use heap. See, from last few days, again and again we had op questions where indirectly or directly we were trying to use heap. So this also is a question like that. Here we are again trying to use heap. What is basically a min heap, I should say. Okay, not just a heap, it's a minimum heap. Min heap means what happens is that, see, it sorts the element in such a way that the top elements remains in the zeroth index. Okay, that is the smallest element remains in the zeroth index, so it can be popped out very very easily. Okay, that is the basic idea. So what we'll do is we'll, as I said, successor and all these things, these will be pushed into the heap, and finally as element will be popped out, which is smallest. And once we pop that element out, we'll push each successor inside the heap. Okay, that's the basic idea. Let me go through some of the basic things here. See, as I told, I will be using a minimum heap. Okay, why the use case is very clear here, because see, we want the minimum out of some of the things. Okay, we know which things to consider. For example, for the first step, after the first step, we know among these two we need a small minimum. Okay, and for the next step, let us say this is included. Okay, this is included, this will lead to two successor and this one. So among the three successor, I need the smallest one. So the use case is very clear. We need the minimum of something. Okay, and every instance, what one thing is happening, one thing is being popped out, and instead of that, two things are being inserted. So it's definitely the use case of a minimum heap. Okay, because every time we have something popping out and something is being inserted. Okay, that is the use case of minimum heap. Now coming to the technical part, see, what could be the structure of my elements in the minimum heap. Okay, so this is the structure. First we'll inside, we'll put this sum. See, structure means, see, the elements will look something like this. Okay, where is it? Yeah, something like this. Okay, so basically, each element of a minimum heap will have three elements. Okay, three sub elements. So what are these? Let us see now. Okay, so the minimum will have, each element will have three sub elements. What are these? The first one will be the sum. Okay, the sum of the pair. Okay, for example, if we take 0 comma 0, that is the sum. See, this is the 0 comma 0. Okay, 0 comma 0 means index 0 of the nums 1 and index 0 of num 2. So it will lead to 1 and 2. Okay, so we'll have the pair sum, which is 3 in this case. Okay, sum of the pair, then the index of the first element in nums 1 and the index of second element in nums 2. So it will be 3 comma 0 comma 0. Okay, the sum, then the index of the first element and the index of the second element in num 2. Okay, so this is going to be my structure of the heap, of each element of heap. Then what we'll do, we, the top element of the heap will be popped out, which is the smallest element. Okay, then we will say whatever is popped out, again it will be stored in three values called val, I and j. Okay, so val is basically of no use because we already know it's the smallest sum. I and j are of use to us. Okay, see, basically we are trying to avoid dealing with same element again and again. Okay, for example, once the element is popped out, or once the element is inside the minimum heap, I should not push it again. That's the basic idea. I will explain that also how it happens. We'll see that. So just remember, I once we have I comma j, this is the one which is being popped out. I will try to see, uh, when we talk about heap, there are two options. Okay, whenever we use this visit thing to ensure that we don't visit same thing again and again, we have two options. Either when we pop them out, we can include in the visited, or when we push them inside, we can include in the visited. Okay, so in this case, what we are going to do is, once we push them inside the heap, we are going to add them in the visited. Okay, this is the strategy which we are following. You can use the other way also. Okay, what idea here is, see, idea is, once the element is inside the heap, I should not use it again. That is, I should not push it again. Okay, I should not consider it again. That's the idea. So what we'll do, once I push something into the stack, sorry, into the heap, I will add it to my visited array, so that the next time when I'm going to add something in my heap, I will check if it is in the visited or not. If it is in the visited, I will not add it. Okay, that's the basic idea. Okay. So this thing, okay. So where I was, yeah. So the top of the heap is popped out. We save that written. Okay, val and I comma j. As I told, val is of no use because we know it's the smallest already, but these strings are of use. Okay. Because first of all, remember for the answer also we need I comma j. Okay, that index we need. Okay, that index value will be what will be the answer. Okay, that's the basic idea. So we put the pair in the answer. Okay, see I comma j is the index, so their values which is nums one of I, then nums two of j. This will be included in the answer. Answer is the one which you are seeing here, right? This will be included in the answer. Okay. Next thing is, see, as I mentioned, this is how we are going to for I plus 1j. For every I comma j, we are going to add these two things. Okay, when I comma j is popped out, okay, these two things will be inserted inside I plus 1j and j I comma j plus 1. Okay, that's what is mentioned here. We push I plus 1 and nums 2 of j, the sum of them in the queue. This is the order how we'll be putting them. So the first element is the sum, as you can see here. Nums 1 of I plus 1 and plus nums 2 of j. This is the first element. The next two elements are its index. Okay, I plus 1 and j. Okay, I plus 1 and j. As you can see here, I plus 1 and this is the j. Okay. This is for this one. Okay. Now for this one, again this element will be inserted now. Okay. Which is nums one of I plus nums two of j plus one, and then the indices. Okay. I comma j plus one. Okay. Now I will show you why we require this thing. Okay. Why do we need to avoid same element getting processed again and again? Okay. I will just show it here. Okay. So we started with 0 comma 0. Okay. We started with 0 comma 0. It became the first element. Then we popped. Sorry. Then we pushed two elements inside. Okay. When 0 comma 0 is popped out, we will be pushing two elements inside. Okay. What is that? 0 comma 1. Okay, 0 comma 1 and 1 comma 0. Okay, these elements are popped, sorry, pushed inside. In the next step, let us say that this thing is the smallest. Okay, this came out to be the smallest. So what will be pushed inside? We will push inside 1 comma 1. Okay, we will push up 1 comma 1 or 0 comma 2. Okay, 0 comma 2. So, and obviously 1 comma 0 is already there. Okay, 1 comma 0 is already there in the heap. Okay, so 1 comma 0 is already there. Okay, now let us suppose this comes out to be the smallest, so it will be popped out. So I will delete it. Okay, I am deleting it here. So 1 comma 0 is removed, but instead of 1 comma 0, what other things will be inserted? 1 comma 1 will be inserted, and 2 comma 0 will be inserted. Okay, we can clearly see 1 comma 1 is already there. Okay, 1 comma 1 is already there. Okay, I will again write here. See 1 comma 0. This became the smallest, and it is removed now. Instead of that, what we are going to add? We are going to add 1 comma 1 and 2 comma 0. Okay, and these things are already there. Okay, these things are already there. We'll just copy it here again. Okay, you can see 1 comma 1 is getting repeated. Okay, 1 comma 1 is getting repeated. That's why we need to ensure that once a thing is inside the heap, we should not include it again in the heap. Okay, that leads to a wastage. Okay, basically instead of that we could have inserted something better. Okay, that's the basic idea. So if you want, I can comment it out so that later on I will give this thing in the comment section of the YouTube video. You can refer it again. Okay, maybe you can do that. So yeah. So let me type P here. P means basically it's being popped out in this stage. Okay, this stage this is popped out. Okay, this is the one which is popped out, and in this stage this is popped out. Okay, so that you understand which one is getting popped out. Otherwise, it's difficult to understand. Okay, so I've done that also. So the one marked with P is getting popped out at this stage. Okay. So now coming to the code. Code is going to be very simple if you understood it till now. Okay. What we are going to do is see once a shortest one is getting popped out, it will insert two of its successors inside the heap. Okay. Then among all the successors which are already there in the heap, we will try to find the smallest. That will pop out, and again it will include two more things in the heap. Remember one thing here. One thing is very strange, which is I have not seen in many of the questions, is that there is no relation given within k and the length of nums1 and nums2. Okay, they have not given any relationship as such. Normally what happens is they will say that k is smaller than nums1 into nums2 length. Okay, like that something, but in this case they have not mentioned. So what are the possibilities? See, what will happen is either we will end up, see, for example, suppose k is greater than nums1 length into nums2 length. Okay, why I am doing nums1 length into nums2 length? Because see, the number of pairs which will form is going to be a total of nums1 length into nums2 length. Okay, if k is smaller than that, it's well and good. If k is greater than that, then we will have to stop it. Okay, then we cannot have k pairs, right? So we'll have to stop at some point. We won't be able to provide all the k pairs. So that is the basic idea. So whatever we have made, that much pairs will be returned. So idea here is, see, two things will happen. Either k will get exhausted. I'm reducing k by 1 in each of the left loops. Once k will get exhausted, that means we have reached all the k the pairs. Otherwise, the min will become empty. Whenever the min becomes empty, that means there is nothing to insert it. Everything is already inserted. So we'll stop there. That's the basic idea. So that this thing also helps us in thinking about the time complexity. We'll come to that. But yeah, remember this. These two cases will always happen. See, these things are very important. See, these things you should clarify if such a question comes in the interview. Okay, you have to ask them very properly that whether k is related to the the length of the given input arrays or not. If it's not related, then these two conditions can happen, and you have to discuss this condition with the interviewer. Okay, if the interviewer says okay fine, go ahead and return, suppose k is much greater than length of nums1 and length of nums2, if into length of nums2, if k is greater than that, you have to tell interviewer that it's not possible to return k steps, k pairs. So he should say what next should be done. Okay, that could form as case. If he simply says okay return whatever is possible, then you need not code for that. That's the basic idea. In this case they have not mentioned anything, so we are going to return whatever is possible. Okay, if k is greater than nums1 and length of nums2 length, we'll return simply the whatever possible pairs. Okay, that's what it is. So that's the idea. See, before coding this kind of solutions, my first advice to you will be go for a brute force approach. Okay. So what could have been the brute force approach? See, suppose this n1 is going to be the length of nums2, nums1, and n2 is going to be the length of nums2. Okay. So if you do n1 into n2, you are going to get the number of pairs which are possible pairs. Okay. What are the possible pairs? See, for each element of nums1, it can be bundled with any of the elements of num2. Okay, like that if you do for every element, you will have n1 into n2 pairs. Okay, you should get those pairs, you should get their sum. Okay, it will take O of n1 into n2, and the next step is you have to sort them out. Okay, sorting will take n1 into m2 into log of n1 into n2, right? Then you will get the first k pairs, which is the smallest sum. Okay, because this current complexity is really high, we are avoiding this kind of brute force solution, and we are going to use the hash, sorry, not hash map, it's the heap solution. Let's see what the answer, what the question is. Okay, sorry, what the answer is. So we are starting from here. Okay, see, basically in Python, sorry, in Leetcode, these things are already included. Okay, you need not include them again, but we are doing this explicitly here. Okay, next thing is m is going to be the length of n1, sorry, nums1, and is going to be the length of nums2. Okay, they need not be same. Okay, it's never mentioned that they can be same. Okay, there's going to be the final answer which you are going to return and visited. As I mentioned, this is needed to ensure that the same element which is already there in the heap is not included again, right? And while coming to minimum heap, we know what is the first element going to be. It's obviously this zeroth element of nums1 and zeroth element nums2. Okay, so and I already mentioned what is going to be a structure. Structure is going to be the sum and the indices. Okay, so we first take the sum and then the indices. Okay, that is the basic structure of it. Then for the visited, sorry, this is the visited set, right? For it, the structure is going to be a tuple of indices. Okay, tuple of indices. First index refers to the nums1 index. The next index refers to the nums2 index. Okay, so it's a tuple. What is a tuple basically? Tuple basically refers to something which is inside a curly bracket. Okay, which is inside a, sorry, circular bracket, right? That's the basic idea. It refers to as a constant in Python. Okay. Suppose you give the square bracket here, it will lead to error. Okay. Square bracket. See, basic idea is whenever you take a set, basically, you cannot have something changeable in it. Okay. When it refers to a square bracket, it can't be hashed, right? That's okay. We'll come to that discussion later. But just remember, you have to use curly brackets here. If you use a square bracket, you can try it once. Basically, you will get error. Okay. Then count we are taking, and yeah, now comes the final thing. Okay. This loop will run till k is either we get all the k pairs or we get the number of pairs, all the possible pairs we get, and the heap will get empty. That is the basic idea. Either one of them will happen. Okay, either we get all the k pairs or k is much greater than n1 and n2, so we'll stop there. Okay, we'll get all the n1 and n2 pairs, then we'll stop, right? This is what is going to happen. So first thing is, this thing is already inside heap, right? So this will be popped out. Okay, remember the strategy. And see, once we push something to heap, we should add it to the visited also. This is the strategy which we are following, right? Other way around is when we pop something, that should be added to the visited. But in this strategy, what we're going is whenever something is pushed inside the heap, this will be added to the visited. Okay, this is the strategy we are following. Now, for each loop, we will pop the smallest one out. Okay, the smallest one will have this value and it will have this index. Okay, in the answer, we'll see whatever the number corresponding to this index, that will be pushed inside the answer. Okay, that's what we're doing here. Nums1 at this index, what is the value that is being represented here? Nums2, what is the value at this index is being represented here. Okay, this is the append operation. Next thing is, as I mentioned, please remember this. Whenever we are popping out something, we'll push two corresponding, see, two successor elements inside it. Okay, so this is what I spent time in explaining with this. Okay, I plus 1 j and I comma j plus 1 for every I comma j being pushed out. Okay, this is what we're going to do. I'm checking if I plus 1 is less than m. because it will ym say m refers to the length of the nums1. Okay, so here m will come. So then I will check if I plus 1j is not in vested. Okay, if it's already invested, it's already inside the heap, I should not push it again. Okay, if it's not inside the heap, I will be pushing it inside the heap. Okay, I will pushing it inside the heap in the the appropriate structure. What is the structure? The sum, then the indices. Okay, the sum, which is this, and the indices. Okay, I plus 1 and j. Okay, inside a tuple. Then I will be adding I plus 1j inside a tuple to the wasted set. Okay. The next thing is, see, I plus 1j is already done. Now j plus 1 and I will be done. Okay. I comma j plus 1 will be done. I will just check if j plus 1 is less than n, yn, and is the for the length in nums2. Okay. So if it less than n, then I will check if I plus 1 and j plus, sorry, I comma j plus 1 is in already invested or not. If it's already invested, that means it's either inside the heap or it's already been popped out. Okay. In that case, I should not, use it again. So I will just push it inside the heap it's if it's not already listed, and I will add it to the listed. Okay. Well, then push the heap, the structure should be followed, which is the sum and then the tuple of indices. Okay. Once this is done, I will reduce k by 1 because we have got one index. See, we have appended something to answer, right? So we have got only one answer. Okay. Now k should be reduced by 1. Okay. This loop will continue to either we get all the k or we get m into n pairs. Okay, m into n pairs. Suppose k is greater than m into n, so we'll stop at into n pairs. That is the basic idea, and finally we'll return the answer. Okay. So yeah, friend, I will just quickly run and show you. It's clearing all the test cases, and if you want, you can comment out this, and then we'll be done. Yeah. So yeah, friend, that was all for today. And see, if you see the time complexity, basically, see, it's a bit difficult. I will definitely agree that it's not that easy to find time complexity of this kind of solutions. Remember one thing here: when we talk of time complexity, here basically two things are happening. Okay, so either this loop will run for either k times, okay, either k times, or it will run for m into n times, okay, m into n times. Okay, one thing is very clear. Okay, so now coming to see each inside the loop, every time what is happening. Okay, two things are happening. First thing is pop operation. See, pop operation is going to over one. That is fine. But there's also a push operation happening. Okay, so whenever we do a push operation, so basically it will take log logarithmic time. Okay, it will take log logarithmic time. So what we'll do is we can do k into log. Okay, why log k? See, basically refers to number of elements inside the k that time. It's changing. Okay, it's changing every time. Okay, so we are trying to take the maximum in the worst case scenario. What is the time, right? So we will take log k time. Similarly, in this case, we will take log of m into n time. Okay, so which see the two things are happening. Okay, either this or this. Okay, any one of them will happen. Okay, because we don't know how this loop will run for how many times, right? If k is smaller than m into n, then it will be for k. If m into n is smaller than k, then it will run for m into n times, right? This is what is happening. So this is going to be the time complexity. And remember why k is coming here. Basically, we are taking the worst case scenario here. Okay, so at most there will be k elements inside the heap. Okay, that's what we are taking. And if m into n is less than k, then this many elements will be there inside the heap. So that is the basic idea, friends. I hope these things are clear to you now and why we are taking this approach. See, you could have see if this comes into a interview question. Definitely, I will expect you to do the brute force approach first. While doing the brute force approach, you will realize that this is see this. Once you realize this fact, I think you can code the solution. Okay, you just need to realize this fact. Either you should realize, or at least by the discussion of the hints of the interview, you should come to this fact. Once this fact is known to you, you can code it in anywhere. Right? You need not use heap or something like that. But if you know this fact, you can manually do it also. Okay, but if you do manually, we have to min off this many things. But what heap advantage is, you did not consider what is inside heap. You can just keep pushing things, and it will again at last return the minimum only. So that's the advantage of heap. Okay. So yeah, friend, that was the idea, and this also I will comment it out, and I will give you this whole code in the description. You can go through these things. Okay, basically what is the happening here. See these things, see what I have shown you. You should try to show in to the interviewer. Okay, these tracings are really important. That's why I also leave them in my solution so that you can also refer. See these things is what the interviewer will be making note of. Okay, whether you are really considering the this is basically the dry run of the solution, right? But basically dry running it before coding it. That's what is really important. See, these things matter a lot when you are come to the real interview. So I hope, see, the ultimate aim of making such videos is that you understand the whole process of what's happening, what's the thinking process, and how the interview things will be unfolded, right? So I hope these things will be of use to you. So yeah, fine. That was all for today. See you tomorrow. Thanks a lot.